Hey guys, we are now going to get into algebra. So we talked about number and quantity, then geometry. Now we're getting into algebra, and this will lead us all up into spring break. So we're first going to start with polynomials. Every single bit of what we're talking about in algebra is a review of stuff that you already know. There's nothing new in this unit. So it's all review of concepts from mainly Algebra 1. So this really doesn't get any more complicated than Algebra 1. So we're going to start off with polynomials and work our way through. And then just know that your test is the 2 days before spring break. So your next test will be April 2nd and 3rd, so make sure you are here for those 2 days. Keep in mind the SAT and ACT test dates. This March 14th one is almost here. And the April 4th one is that first weekend of spring break. So after this test, those of you who have already registered for the ACT for April 4th will take it the very next day. So what we're talking about is very, very important. And just make sure you guys are taking both the ACT and SAT this semester so that your senior year you can focus on the one that you do better on. So now we're going to get into polynomials. Like I said, this is all review of stuff that you have seen before. None of this is new. So let's talk about classification of polynomials. A monomial means it has one term. And then if it has a degree of 4, remember degree is the highest powered exponent. So degree equals highest exponent. So if we look here, the highest exponent in all of these is in this one 4, 2, and then here, remember if it doesn't have a variable, that's the same thing as saying x to the 0, because x to the 0 is 1 and 5 times 1 is 5. So anytime you have just a number, it's called a constant, and that's when it's raised to the 0. X is raised to the 0 power. So there is a variable there. It's just raised to the 0 power, making it be 1. So if it's to the degree 4, it's quartic. If it's degree 2, it's quadratic. And then if it's raised to the 0 power, it's called a constant. If we look here at a polynomial, anything that it has 4 or more terms is a polynomial. And so here my highest exponent is 4, so it's quartic. 6, you don't really need to memorize that. Once you get to quartic, and it kind of goes from there. Here again, I'm looking for the highest exponent. It doesn't always have to be first. My highest exponent here is 4, so it's still a quartic. So there's 2 names. One is based on the number of terms, and then the other one is based on degree. So again, 1 term, it's a monomial. 2 terms, bi meaning like a bicycle has 2 wheels. Tricycle has 3 wheels, so a trinomial is 3 terms. And like I said, 4 or more, we just classify it as a polynomial. And then again, if it has a 0 term, it's a constant. Not 0 term. 0 degree is a constant. If it has a degree of 1, it's linear. Remember, this p is still raised to the first power. And then if it has degree 2, it's quadratic. Degree 3 is cubic. And degree 4 is quartic. The higher ones you really don't have to memorize. So these are all examples of polynomials. Note you cannot have a negative exponent. No radicals or fractional exponents. Remember, we can write a radical as a fraction exponent, so you can't have any of that. And no variable as a denominator. So these are all the examples you cannot have in terms of a polynomial. So if you see any of this, the rules for polynomials don't work for this. Okay, so now getting into adding and subtracting polynomials. So it says expand and simplify, we're just adding and subtracting. So let's look at this first one. Actually, let's look at B first. So you're just adding. All you do is remove the parentheses and write this without the parentheses. So all I've done is rewritten this entire expression without the parentheses, and now you just combine like terms. So, if we're going to write it in standard form, we always start with the highest exponent. So in this case, it's the exponent of 4. So this one right here. We look, does anything else have an exponent of 4? No, so it's negative 3x to the 4th. Then we go on to cubed. So we have 5x cubed. I have another one right here. 5 plus 3, remember you're only adding the coefficients. You're not doing anything else with the variable and exponent. So 5 plus 3 is 8. So 8x cubed. And then we go to x squared. So we have negative 9x squared goes with this positive 2x squared. A negative 9 and a positive 2. They have different signs, so we subtract. 9 minus 2 is 7. And we take the sign of the highest number, which is 9. So it's a negative 7x squared. Then we go on to our linear term. In this case, we have a negative 2x and a negative 5x. Same signs, add. So 5 plus 2 is 7. And we keep the sign, which is negative, so negative 7x. And then the last thing is our constants. And we have this negative 2 and negative 7. Same signs, add. 7 plus 2 is 9, and they're both negative, leaving this number negative. Okay, if we talk about this, we have a degree of 4. So this is a quartic. This is the degree. And this is a quartic. And then I have more than 4 terms, 4 or more. So this is just labeled as a polynomial. The number with the degree, this is our leading coefficient. And all of these behind it are just called coefficients. They're the numbers in front of variables. So let's go back to A. We have this negative, a subtraction sign. So we're going to distribute this sign to everything behind it. So just the parentheses behind that negative. So we're going to rewrite this 7x plus 3. And then now distribute this negative. So a negative and a positive makes it a negative 2. Negative and a negative makes it a positive 2x. And now we do exactly what we just did on part B. So we start with our highest exponents, which is 1. 7x plus 2x gives us 9x. And then we have 3 minus 2 gives us 1. The degree, remember, x is always raised to the first power if it's not written in. So this is your degree. This is a linear function. And because it has 2 terms, 2 is binomial. Okay, now let's look at some more problems. If we look at part C, I see a number, a monomial, next to the parentheses. That means to multiply to everything in the parentheses behind it. So we're going to distribute this 3 to both the x and the 5. So 3 times x is 3x. 3 times 5 is 15. And then we just bring down this 8x. Now combine like terms. We have the 3x and 8x, which gives us 11x. And then we're just left with this 15. Again, this x is raised to the power of 1. So this is a degree. And because it's 1, it's linear. And again, it's a binomial because it has 2 terms. Same thing works for all of this. Let's go on to G. We are going to have to distribute for this one. So we're going to take this first monomial, this first term, which is x, and we're going to distribute it to everything in the parentheses behind it. So x times x and x times 5. So x times x is x squared. X times 5 is 5x. Okay, we're done with that x. Now we move on to this 3. We're going to do it to the same things. 3 times x is 3x. 3 times 5 is 15. Now we combine like terms. There's nothing else but this x squared. Now we look at 5x and 3x gives us 8x. And then we have the 15. This has a degree of 2. So this is a quadratic. And it has 3 terms, making it a trinomial. We're going to do a couple more examples just to make sure that you guys have this, and then we're done with polynomials. So Cameron Ball, Julissa Gonzalez, Brianna Brown, I need you guys paying attention. So here we go for H. You cannot distribute this too. That's a no-no. What this means is that you are multiplying 2x minus 5 by itself 2 times. So we're going to do 2x minus 5 times 2x minus 5. And now we're going to do exactly what we did with part G. So Trigger Davis, listen up. We're going to start with this 2x. We're going to distribute to the 2 terms behind it. Multiply the 2 coefficients. So 2 times 2 is 4. X times x is x squared. Now we do the 2x with this negative 5. So 2 times negative 5 is a negative 10. And that x just goes behind. And now we're moving on to this negative 5. We're going to distribute this. Negative 5 times 2x is negative 10x. Negative and a negative makes this a positive. 5 times 5 is 25. And now we're going to combine like terms. So what goes with this 4x squared? Nothing. And then now we have our negative 10x and negative 10x, same side. So we add 10 plus 10 is 20x. So remember, when we multiply, the exponent gets bigger. When we add, the exponent stays the same. So it's just a 20x. And then lastly, we have this 25. So Diamond Thurman, remember, you have a test on this coming up right before spring break. Thanks, guys.